Hello and welcome to day 9 of Advent of Code 2024. In this puzzle, we are going to do some disk fragmentation. We are getting an input which is like this, and this shows the layout of files and free space on the disk. And these digits alternate between the length of the file blocks and the length of free space. So here we have a 2-block file, and then 3 block of empty space, then 3 block of file, then 3 block of empty space, 1 block of file, then 3 empty space, and so on. Also, each of the files that we have here in this file system has an ID number that is based on the order as they appear before they are rearranged. So if we go down, so let's go to, for example, this example, which is much smaller and easier to understand. This means that we start from ID 0, so the disk map would be like this: a 1-block file with the ID of 0, then 2 block of empty space, then a 3 block of file with the ID of 1, then 4 empty spaces, then 5 block of file with the ID of 2, and so forth and so on. So if we have this kind of representation of the file, if we want to map that, it would be something like this. So 1 block of file with the ID of 0, then 2 block of empty space, 3 ones based on this, and so forth. Now, based on our logic, something like this would be represented as this. Now, we would like to move the file blocks from the end of the disk to the empty space in the front so that there are no gaps between file blocks. So we want to remove these gaps that we have here. So if we have something simple as this, we would move these two to here, then these two to here, then these two to here, these two to here, until we get to this, and the rest is empty space. So based on this scenario, if we have the input like this, which is converted to a mapping like this, then we could defrag this in these steps. First, we get the first 9 here, put it in the first empty space, then the second 9 here, and so on until we get to this final state. Now, the answer that we want to provide is just multiplying the position by the number. So here 0 times 0 plus this 0 times 1, then 2 times 9, 3 times 9, 4 times 8, 1 times 5, and until to the end. And we add all these numbers together. Okay, let's go and see it in code. Now, if I open file part 1, and let's say make this a little bit bigger, so more visible. Now, as always, we get the data. This time we only split it by empty string and map to number, because the input is a long string, so we don't need to map it to a grid system or anything. So our data is a one-dimensional array here with numbers. Now, we define an unpacked disk because we want to first unpack that, meaning convert it from something like this to something like this. Now, the thing that we do is take a look at the data that we have, and for all the numbers that we get, we provide the string in the final unpacked string. So we start from index 0 and say, okay, now we are at index 0, which is this one. Now we get 2, so we need to provide 2 zeros and put it here. Okay, index is 0, the number is 2. So this is for going through the string, and this is for the number that is inside the string. We divide I by 2 to get the index and push it here. So if we are at index 0, we need to add 2 zeros. If we are at index 1, which is here, we need to add 3 dots here. That is done here. if we are at index 2 here, the index of the file would be 1. We are at index 3 of this string, but the index of the file would be 2 because would be 1, sorry, because this is index 0, this is index 1, this is index 2, and so on. So that's why we are like dividing by 2. So if this index is 0, we provide 0. If index is 2, the file representation is like providing number 1 here. Then again here, if we are at index 0, 1, 2, 3, and 4, then we need to provide 2 here. Okay, so this way, using this logic, we can get the unpacked version of the string that we get. Now for the defragmentation, which is converting this string into something like this, we need to go from here and from here. And when we get to a number here, we push it to the first empty spot that we found in from the beginning. Okay, so for all the characters or spots that we have on the unpacked disk, we get that block and its index. Now, if the block is dot, which means that we found an empty space. So we are starting from here, we go here, now we find the empty space. Now we stop here, and then we would do a while loop from the end to find a number. So we would say while true, we pop from the unpacked disk. If that number is dot, then we continue, we don't care. So it's a state like this. So we're here, we come to this point by using this for, and by using that while, we would skip these two and get to here. Now when we get to here, we add the number that we popped to the unpacked disk. So we get this number and put it here, basically. And we continue until the defragmentation is done. This would unpack our file. And the thing that we should do in the end is that for all of the blocks that we found, we just add those numbers together. And by the way, when we do the pop here, we just remove the dots. So in the end, this unpacked disk will not contain any dots here. So if I run part 1, you can see there is no like dots here. So all the empty spaces are removed from the final answer. Now to part 2. On the part 2, the things get a little bit different. After doing the unpack string that we want, now we want to move the files all at once. So we are here at 99. We go from the beginning and see if we can find the spot that is at least 2 spots big. If we found that one, then we move 99 all together to here. So from here we get to this. Now we get to 4/8. Now we need to find a spot here with 4/8. If we find that, we are good to go. If we are not, we leave the 8s as they are. We go to 7s. There are 3 7s. We have a spot here, so we move this here. So now our input is like this. And the point is that we don't go back again. So we are here, we go to 666. Do we have place for it? No. We go to 555. Do we have any spot for it? No. We go to 444. Do we have any spot for it? Yes. We put 44 here. Then we get to 33. Are there any spots here? No. So we are fine. And we are not going back to the beginning and searching this way. And we are not like moving the files in this direction as well. So let's go to the code. On the part 2, let's make this a bit like this. The thing that we do is, instead of part 1 that we put individual blocks into the unpacked version, this time we move them as blocks. So in part 1 we would take this and then move it individually, but now we want to move them 2 by 2. So for that reason, when we want to do the unpack, we would provide the data as to the array, just like this. So for that reason, first I would define a file and I would do the same thing that we did for part 1. So let me open part 1 and put it side by side. So just like here, we have something like here, but this time instead of pushing it into the unpack this, we push it to the file. Then we push that file, which is an array, into the unpack this, and the result would be something like this, an array like this, which each item represents the files. So we have 2 blocks of 15, 49, like 5 or 6 blocks of empty spot, and so forth. Okay. Then now we want to move the IDs. So I don't need this anymore. Now here, again we would start from the end of the file because this is asked from us to do it from the end, if I can find it. So now, decreasing file ID number. So we need to start from the end. Now we start from the end of the unpacked disk, which is, for example, in this case would be somewhere around here, but let's say we have 51 items, so this would be the end one. Now, when we have this as the end one, we take a look at the first item, which is this. Is it a number or is it an empty space? If it's a number and we have not moved it yet, we can move it because it says we need to only move once. So we shouldn't like look for 51 if we have passed that one. If the unpacked is not dot, which is this case not, and the moved IDs does not include this, so 51 is not moved yet, we search for an empty spot in the rest of the arrays. So here, we would search from the beginning of the file until to this point, so we don't go further than 41. If the thing that we found is a dot and the length of this is greater than or equal to this 51, then we can move it. So this is where the move happens. Now, if they are the same size, we just move the whole file, this 51, to this spot altogether. This is doing like this. So we provide an empty array and push it into the unpacked file. And then we would continue to the outer. So we don't need to continue this for loop because we have done our move. We move to here and continue to the next block of the file in the unpacked system. Otherwise, if the length of the empty space is greater than the length of the file that we want, then we just splice. Meaning that if this is 7 and this is 8, we move like 7 of these 51s to here and leave the last one free. So this is done in this manner. Okay. Then again, we would continue with the outer. But if we don't find any empty space for this 51, then this 51 stay as is. We go to the next one. Next one is dot, so we don't care about it by checking this. Then we go to 50. We look for the empty space and we go on and on. Okay. And in the end, we just flat this. So because in the end we would just have a 2D array and we want to, do the checksum. So we need to flat it to become a one-dimensional array. And now our array would include some empty spot. So we need to skip those. For all the items that are in the diff rag, we get the block, which would be this number, and its ID. And if this block is a dot, we skip it. If it's not a dot, then we would just do the multiplication and add to the checksum and return the value. So the point here was to always continue to the outer, so when we do the unpacking we don't need to continue doing this for loop, and this is done by this, just continuing to this part. And yeah, that was it for this puzzle. I hope you enjoyed the video, and see you in the next one.